because this is a really important concept for any sort of distributed architectures. We have to know what's going on inside our applications so that we can keep track of it and we can make it better. And so monitoring is basically how you do that. But monitoring at scale gets to be pretty darn complex, and that's the interesting part about it. If you want to just, throw Nagios onto one machine and see what that one machine is doing, fine. But if you go to 10 machines, fine, Nagios still works, it's still okay. But when you get to distributed market monitoring at scale, where you have hundreds or thousands of machines, there's just no way that Nagios can scale up to that. So monitoring at small scale, easy. Monitoring at big scale, really complicated. I've stolen, liberated the slides from a presentation that was done by a guy named Caskey Dixon, who was at Google at the time. I think he's at Microsoft now. And he did a presentation at a LISA conference, a Usenix conference, and it was just really well done. And he got across his concern about how to get to scale. And so monitoring and the reasons to do that, that's probably the best part about this. So let's take a look at some of his slides. I'm going to skip through some of them pretty quickly. I'm going to post a link to the original presentation so that you can watch the whole thing in its entirety. It's worth watching. He's a good guy, and really interesting stuff. So, a working theory of monitoring at Google, and this is from 2013. You'll notice his title, Site Reliability Engineer, and that's kind of a Google job title. It's really interesting. It sounds like it would be a fun job, if you ask me, where you get pretty good span of responsibility, and you get to figure things out, and that's the most fun part. So anyhow, working theory of monitoring. So what are metrics? The assignment of numerals to things so as to represent facts and conventions about them. It's hard to figure out what are we measuring? How do we measure things that happen in computers? Our computers can generate thousands of metrics per millisecond, probably second. But which ones are important? Which ones are the ones we want to keep track of, and which ones we just, don't care less about? Because we're humans. We can't keep track of huge numbers of metrics at any given time. And we've got to find a way to represent those metrics. So metrics represent activity on the machine. Now we've got to find a way to represent the metrics to make them operational, to make them useful, and not just numbers that mean nothing. So why a theory? Monitoring seems easy, and it's not. And if successful, we should be able to sensibly map many monitoring methods and modes into a good model with fidelity. Fidelity means that it represents reality, and so this is where it gets complicated. So what do we monitor? So this is one of the key points. So what's a metric in this case? It's a named value from a source, from a device at a time. So you've got to have a value that you're representing that has a source that tells you where it's from and a time. So here's some metrics that he's got here. www-1 na-east.example.com. Now that's the name of the device, and then he's got HTTPD 3321. That's the named value. I'm sorry, the source was www blah blah blah, and foo.example.com 200 OK count. So we have a host name, a process, a vhost, and a name. And that's the kind of stuff that we always need. Then we have what kind of values do those metrics represent? Are they counters? Are they gauges? Are they percentiles? Are they nominal, ordinal, interval, ratio, derived? All that kind of stuff matters. And then they need to be time stamped. And so here's a real metric down at the bottom where we've got a source, we've got a process 200 OK count, and then at, and then a time. I'm sorry, the time is the at 2013, blah, 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 blah. And so these get, they're short as text entries go, as log file entries go, but they still have a lot of information in them. And without any of that, any one of those pieces of information, it would be useless. So, and imagine trying to scan through a whole file full of those numbers. What would they mean? Nothing. Nothing to a human. So how can we monitor? So this is another question that comes up. Resolution, latency, and diversity. Resolution, how frequently are you reading a metric? Every 6 seconds, every 6 minutes, every month. It just depends on what the metric is. Latency, after reading the metric, how long before we act on them? So, seconds, minutes, hours, it all depends. And then diversity. Are you counting many different metrics? Or are you counting one? Can you narrow down the state of your server system application can be measured through one metric? Some of them we can. Think about business metrics that are like, what's our conversion rate, which is the number of people who come to our site to browse, but then actually buy something. That's got a resolution that we read, once a day, once a week, once a month. It's got latency. We can act on that for a long time. We're going to want to see that over months. And then diversity, well, very low. So, the kind of metrics that we gather really determine what we're looking for. So if we have different consumers for our metrics, so our operational health and response, this is kind of us. We're going to have high resolution, low latency, and high diversity. So high resolution, let's go back. How frequently are we reading a metric? We're reading it very frequency. We're going to have low latency. After reading, how long before we act on it? Very short amount of time. And then high diversity. We're going to have a bunch of different metrics. That's us, operational safety, operational health and response. But let's look at our capacity planning. In capacity planning, we have low resolution, so we don't take our values very frequently. We have high latency, so we don't act on it very quickly either. And then we have high diversity, where we have lots of, there's the resolution, latency, diversity. So we have high diversity, so we're looking at lots of different metrics. That's for capacity planning. And so, we have different consumers of the metrics that we gather. Now, the problem is that we're the ones that gather all of this stuff. Monitoring is something that ops people do. And so because we do it, but we have to do it for lots of different people and lots of different groups, we have to find out what their desires are and find out, so that we can gather the information that they want, store it, make it available, all that kind of stuff. So monitoring at scale, well, it's easy. If you're monitoring a web server in a database and you got a monitoring server, you get about 25 metrics per server per minute. That means about 50 metrics per minute. Easy peasy. If you have 100 active daily users, that means 100,000 active daily users. That means we're getting 200,000 peak queries per second, just as ballparks. that means that if we get 20 queries per second per server, and we have 10,000 servers, that means we're getting 25,000 metrics per second. So, it scales up really, really quickly. So about 166 metrics per second. And then if you start adding in more servers, then it just gets even more complicated to the point where we're at 10,000 metrics per second. And then if we're doing this globally, we could get 13,000 metrics per second going someplace. It gets big very, very, very quickly. So, what you're going to end up doing at this scale is you're going to have a totally separate monitoring system that is going to do nothing but monitor things, which doesn't make anybody any money, but that's all it's going to do. And you're going to have people whose jobs are just running the monitoring service. So, boy, that escalated quickly. Was that Ron from Anchorman? Yeah, Anchor somebody or other. So what do we monitor? Just to recap, named, sourced, time-stamped values of different types, gathered at high resolution because you can't gather at low and then produce reports at high. Large quantities, many different consumers, and reliability matters. So here's the architecture that they use for their monitoring system, which is really pretty cool, I think. And we'll go through this, kind of step by step. So right on top we have sensing. Sensing is gathering the metrics themselves. So there's no consistent interface for this, but it's just different ways to gather metrics. Storage occurs every place across this. So we have sensing, collection, analysis, computation, alerting, and visualization. But storage occurs throughout, as does configuration. So we've got a lot of storage going on here and a lot of things that need to be stored. Collection is taking all those metrics and bringing them all together. So let's see. So so we've got all these different machines that are sensing themselves, taking the metrics, but now we've got to gather them together to do something with them. And the first step that we do is the analysis, where we extract meaning from the raw data. It's still very, very raw and hard to do a good job on. Alerting and escalation. So what do we do with this stuff? When our analysis points to something, what do we do with it? Well, we need to, turn on the light on top of the helmet there. And so that people who can do something with this information are able to do something with it. And then visualization. The problem that we have as humans is that we can't scan through those log file entries very well and see what's going on with them at scale at all. And even visualization of these large numbers of metrics gets really complicated because you've got those 3 or 4 different dimensions to each one of the metrics that we have, and so you're at multi-scale. You're at 3 dimensions at least, and our screens are only 2 dimensions. So that visualization is a really hard thing to do well. And then turning that visualization into something that's actionable, that really matters too. In the video, if you watch the video, he hates this one thing where you look at the disk utilization. This thing, everybody's got pet peeves, and this is Caskey Dixon. So I'll let him go through it if you watch it. It's really interesting. So configuration affects every layer, and in your lab where you add a monitoring layer to your lab architecture, this is why. So configuration goes throughout the whole monitoring process. And we've got to have configuration management. We've got complicated distributed systems, and limits change velocity. So our speed at which we can change things is limited by our configurations. It's kind of cool. So we did this before. So here we just have some different users of the information that we get from our monitoring systems, product management people. I mean, it would be nice if we didn't have to worry about products and the business measures and stuff. But the fact of the matter is that we want to get paid. And so to be paid, we've got to make our systems make money. And so that means product management and supporting their needs for monitoring. Capacity planning, we looked at some of these things. These are some of the metrics that they're interested in: cost per user, efficiency, calculation of proxy metrics, quality assurance, developer support, collect data from both narrow and wide views. They have a very different set of needs than we do. And here, we're interested in reliable and flexible alerting, storage of enough time series at high enough resolution for comparison. So remember, if we gather all these metrics into one location, we're going to want to store some of them, but not all of them. And some of them are going to be not the raw values, but the computed values, the initial stage of analysis already done. Another place where this gets complicated, when you're going to do this over time, longitudinally, that means over time, you're not going to keep all of the data. So some of the data you're going to let go. And when it's gone, it's gone. And then some of it you're going to do a partial analysis of so that you can compare across longitudinally over time, but not the raw values, the computed values. It gets complicated. Let's see. Okay, blah, blah, blah. All right, so this is, all right, so here, so the later part of the presentation, he goes through and talks about all these different products that they use. I deleted those because, if you want to watch those, that's really interesting. It's fascinating is what it is, but they string a whole bunch of products together that at the end generate the visualizations that they can use to make their decisions with. That's how they do it. So yeah, watch it. It's worth watching. And let's see. So here we're just kind of looking at our model here, and who's looking at different parts of